Okay, so let's start on the process of cellular respiration. So when we look at cellular respiration, it's broken up into three stages. We have glycolysis, citric acid cycle. This has another name also. It's also called the tricarboxylic acid cycle, and it's also called the Krebs cycle. I will often refer to it as the Krebs cycle just because that's what I always learned it as, and it's what pops out of my mouth. So we have glycolysis, we have the Krebs cycle, or citric acid cycle, and we have a process called oxidative phosphorylation, which is actually going to be two steps together. So I'll go over those individually. So when we look at glycolysis, there's some key things that you have to know. First of all, you're going to take a glucose molecule and you're going to break it up into two pyruvates. That's one of the things that I want you guys to know. This also is going to occur in the cytoplasm, so it's just happening all over inside the cell, nowhere specific, it's just the cytoplasm. And you're going to get ATP and that molecule NADH out of this, and I'll come back and give you those numbers. Now when you look at the citric acid cycle or the Krebs cycle, this is going to happen in the mitochondria. So both of these are actually going to happen in the mitochondria in the presence of oxygen. So you need oxygen for these guys to happen. So citric acid cycle or Krebs cycle and oxidative phosphorylation are going to be happening inside of the mitochondria. This will also give you some ATP and NADPH and another molecule you'll learn called FADH2. So just like NADH, that's an electron carrier. And then this is going to give you ATP, lots of it. So we'll talk about, once again, numbers coming up. Okay, so if we visualize these processes, we're going to start with glycolysis. And glycolysis is always the first step. So you don't have cellular respiration without first doing glycolysis. And this is happening in the cytoplasm. And we're going to take a glucose molecule, convert it into 2-pyruvate. So in the cytoplasm of the cell, glucose being converted into 2-pyruvate is glycolysis. The other thing that's coming out of this are NADH molecules. And remember, they're electron carriers. And there's 2 of those coming out. And there's also ATP coming out. And there's going to be 2 of those. So 2 ATP, 2 NADHs, and 2 pyruvate going from the breakdown of glucose, and that is glycolysis, and once again it's in the cytoplasm. So from glycolysis we can then go into the citric acid cycle. It's also called the tricarboxylic acid cycle. It's also called the Krebs cycle. So we're going to take the pyruvate that was made here, we're going to ship it into the mitochondria to do the Krebs cycle. So once again, this is going to occur in the mitochondria. And just going back really quickly, if we look at glycolysis, glycolysis, you guys should know by now that base word lysis means to break. So we're breaking glucose. That's what that's referring to. But when we get to the Krebs cycle, that's happening in the mitochondria. And out of this, you're going to get, once again, NADHs, and you're going to get FADH2s. Now, in this case, the NADHs and FADH2s, the numbers you're going to have to know also. For FADH2s, there's 2 of them, and for NADHs, there's going to be 6 of them. 6 NADHs, 2 FADH2s, and there's also ATP that comes out of this, and there's going to be 2 ATP. Then our final step is called oxidative phosphorylation. And oxidative phosphorylation has 2 parts to it. So you have one part called the electron transport chain. You have another part called chemiosmosis. So they collectively make up what's called oxidative phosphorylation. And this is where a huge surplus of ATP is going to come from. Now, the numbers you get out of this range, current research actually suggests it's down around 28. But most things that you see and we talk about in lab, it's going to be between 32 to 36 ATP. So that's a number you're going to have to know. 32 to 36 ATP come out of oxidative phosphorylation. Okay, you're going to have to know the overview of these processes. The good news is you're not going to have to know the details. And I'm going to start with glycolysis. Once again, going over the overview. I'll show you the details just to give you an idea. For instance, those of you guys that are going on in science, you might have to take something like biochemistry. In biochemistry, they'd love to take glycolysis and the Krebs cycle and the electron transport chain and break it up into the individual chemical reactions. So I want to show you those, but you really just have to understand the overall process and what I've already described. So glycolysis, we're going to take glucose, we're going to split it apart, hence the term glycolysis, breaking sugar. And out of that, you're going to get 2-pyruvate. That's a part I've said multiple times you have to know. You're going to get 2 ATP, and you're going to get 2 NADH. So there's two things going on. You have an energy investment phase where you have to actually put energy in, and then there's an energy payoff phase where the energy comes back out. So let's look at the details, but once again, just knowing the overview for the exam. All right, so when we look at glucose to pyruvate, we're going to look at the idea of what goes in, what comes out. So we have glucose going into this reaction, and we're going to put ATP in, so that's the energy investment phase. And once you convert that down, there's going to be 4 ATP coming out. But I told you guys there's only 2 coming out. Well, the 2 is the net total, because if you use 2 and you get 4, you're only left over with 2. So you're getting a net of 2. You're also getting those 2 NADHs. So glucose to 2-pyruvate, you get 2 ATP and 2 NADHs. And of course, you have to know, where does this occur at? It's in the cytoplasm. Okay, I want to show you guys the details of glycolysis. You do not have to know the details for the exam. For the exam, you have to know the base idea of what's happening. So once again, just to review the base idea, you're going to take glucose. You're going to convert that to 2-pyruvate. You're going to get 2 ATP. You're going to get 2 NADHs. And this is going to occur in the cytoplasm. That's the basic idea of what I want you guys to know. Just to build your background, let's go through the details. So first of all, you're going to take a glucose molecule with energy. So there's 1 ATP coming in. An enzyme called hexokinase is going to convert it into glucose 6-phosphate, which just simply means it's a glucose with a phosphate on the 6th carbon. Okay, so glucose 6-phosphate is then going to be converted to fructose 6-phosphate. And remember, glucose and fructose are isomers of each other, and that's converted by this enzyme. It's an enzyme because it ends in ase, and it's a isomerase, which means it converts the glucose into its isomer. So now we have fructose 6-phosphate using an enzyme called phosphofructokinase. It's converting it to fructose 1,6-bisphosphate with a phosphate at the 1 and 6 position instead of just the 6th position. And the key here is 2 ATP going in, 1, 2 total now. So you had 2 in the energy investment phase. Now the fructose 1,6-bisphosphate is going to be converted via aldolase into 2 isomers, dihydroxyphosphate and glyceraldehyde 3-phosphate. So dihydroxyacetone phosphate and glyceraldehyde 3-phosphate are isomers of each other, and another enzyme called isomerase can actually convert them back and forth. Now once you go into the pathway of the glyceraldehyde 3-phosphate, that's going to be converted into a 1,3-bisphosphoglycerate, and that's done by an enzyme called triose-phosphate dehydrogenase. And here's a key, you get 2 NADHs coming off. That's something I told you guys had to know. We take the 1,3-bisphosphoglycerate using an enzyme called phosphoglycerokinase, convert that to 3-phosphoglycerate. But here's something, 2 ATP come out. But what to keep in mind is that we've put 2 ATP in so far. So 2 have gone in. Right now we've gotten 2 ATP out. So our net total is 0 ATP as of this moment. 3-phosphoglycerate is then converted into 2-phosphoglycerate by an enzyme called phosphoglycerol mutase. The next step is taking that 2-phosphoglycerate, converting that into phosphophenylpyruvate by an enzyme called enolase. And then finally, we take that phosphophenylpyruvate, convert it into pyruvate. So there's the 2-pyruvate to come out. And what does this is an enzyme called pyruvate kinase. And here's the 2-ATP coming out. So remember, previously I said we're at 0 ATP, but we now have 2 more coming out, so we're gaining 2. The good news is you do not have to know those enzymes or those steps. What you have to know is you get 2-pyruvate, 2 NADHs, 2 ATP, and you did this in the cytoplasm. But keep in mind that this is not as simple as knowing glucose to pyruvate, 2 ATP, 2 NADHs. There's 10 different enzymes that are controlling every step along the way. So I think it's worthwhile at least seeing those steps, even though you have to know the basics. 2 NADHs, 2 ATP, 2 pyruvate is what you get out of this process. Once we get through glycolysis, we now have pyruvate. Now what happens to pyruvate depends on the presence of oxygen. If there's oxygen present, we're going to go into the mitochondria and we're going to go through making the Krebs cycle and oxidative phosphorylation. If there's no oxygen present, something else happens, and I'll come back to that. So in the presence of oxygen, pyruvate is going to go into the mitochondria. But in order to get it into the mitochondria, it has to be converted into another molecule first. And that molecule is called acetyl-CoA. So acetyl or acetyl-CoA, which is actually a form of vitamin B. You don't have to know that specifically, but you have to know that acetyl or acetyl-CoA is what's needed to get you into the mitochondria. So here we have pyruvate. This is the membrane of the mitochondria. And to come in, we have to convert into acetyl-CoA. So pyruvate is converted into acetyl-CoA, and that's going to be done to start the Krebs cycle.